Yes. Okay. Very good. Um, yeah, as Amber already mentioned, we'll talk about renderings today. How can we set up a scene? What do we need to take care of? A few tricks that I found out over the time. It will be a bit more interactive, I hope at least, so if you have any questions, please post them right away as we go. So there won't be a Q&A at the end. I'll just try to cover your questions immediately, maybe show you, because it will also be less of a presentation, but it will be more of a workshop today. I'll turn off my camera, just to have a bit more bandwidth on my presentation. Now, is this movie smooth for you? If not, we will post links in the comment section, in the chat, to our YouTube channel that contains like the stuff I'll be showing today. Okay, so let's get started. Before we go into actually building some small scenes, a bit choppy. Okay, not as smooth as used to. Okay, that's fine. Again, Amber, maybe you can post the link to the YouTube playlist, and people can just click the videos that I'm showing here, so they have a smooth experience. Yeah, ray tracing. It's a very okay. Link is coming in. It's a very nice feature to render realistic images. Now, in reality, we'd have some kind of. Let me maybe do this. We'd have some kind of light source. This would emit light that we would then perceive with our eyes. That would be super inefficient. So what we do in computer science, scientific rendering, or also any kind of scientific rendering, is we do it backwards. We trace rays coming from the camera. Assume this is what you see through your screen. So we are not like wasting computation on these irrelevant race. So, but in any other sense, it is very realistic, really how the light interacts with objects, how rays bounce off of materials, transparencies, like all that stuff can be done with ray tracing. And that's what makes it so realistic, so appealing, but also so expensive, in terms of computational resources. Now, when we're talking about data, it's like we are very privileged. Working with CFD is really, I think, the most rewarding field in terms of visualization, right? But we have these billions, millions of data points that we need to choose from, right? What do we want to show? What message do we want to get across? Even before that, what kind of data are we saving? And very importantly, at what frequency are we saving the data? Now, 2D slices, I mean, they are not super interesting for this webinar. We really focus more on 3D stuff, because I think for these slices, just regular rendering is way better. It's very clear. It gets your message across. You can use something like surface LIC, for example, to even show some flow structure. On the leftmost one, you can see the Y velocity with a diverging color scheme. So blue colors indicate descending fluid, red colors indicate ascending fluid. So there's already a lot of stuff you can do. And one thing that you'll notice here, when you tried to use the surface LIC, something unpleasant will happen. Let me demonstrate and maybe show you a little workaround. So let me just bring up post. Flow only should be fine. Okay. Yeah, I mean, this is pretty much what you're used to, right, when you open MStar. Now let's focus on this plane here. In 3D and 2D space, right, we need to map the data to colors, and in this case also to transparency or opacity. As I was saying, if you want to show structure and use that surface LIC feature that you can see here, you'll notice that we can see that stuff that is outside of our domain. And this is something we don't want. And there is an elegant little workaround. Well, I don't know if it's elegant, but it works. By the way, I usually go with LIC only for the contrast, and then you can turn it all the way up to 1 to see only structure, or go to 0 and you'll have the natural image. Now let me show you the workaround. We can use a threshold filter to get rid of everything we don't want to see. Let's do it, threshold, and then I can pick something like volume fraction, go from 0.5 to 1 or above. And, since this is live and I'm just showing stuff as we go, things will go wrong. I hope it's not too much, but maybe we're encountering the first little crash here. That's unfortunate. Let's try again. But these things happen, like especially when you're doing more complex scenes, it will actually happen quite frequently. So be prepared to always save your state file. That's really important when you're building more complex scenes. Let me try again. Threshold, volume fraction, 0.5, for example. Okay, that was the wrong one, but it didn't crash. That's good. Where is it? Here it is. Okay, now we have it. And now we can do surface LIC, and we got rid of that, dead space up here and down here. The same is true when you want to plot data that goes from negative to positive, because these empty cells will have zeros. So if we go for something like, as I've just shown, the Y velocity, it will not show up correctly here, but here I'm getting rid of this. While we are at it, let's maybe just reconstruct that small figure I just did. You probably all have seen these different colors, right? I can expand this. If I select all, I'm getting all of them. There's a lot of good ones here. Diverging might be good for these cases. And let's just pick one with black in the middle, because I think it looks kind of nice, and then you might want to make it symmetrical. How much GPU power are you using for this rendering? I'm just using a laptop, a gaming laptop with an RTX 4090, which is, in the laptop space, a high-end machine. But I think like any modern gaming GPU does the job. And for the more advanced ray tracing methods, we are also relying on CPU. So yeah, just try it. You might encounter some limitations, but should be fine. Okay, so yeah, I mean, I think this is pretty much all I have to say about 2D, because again, this is not what we are talking about today. Because also 2D might even be a bit misleading. When I was starting CFD, I just knew about these 2D slice images. They were everywhere, and there was pretty much not much else. I mean, some people like Harry van den Akker really looked closer, but that was the exception rather than the rule. So when we go over into 3D space, we're adding a whole new dimension here, going from 2D to 3D, obviously. And now you can see that most of this motion here is tangential, and not axial. Here is a small comparison, and this is kind of what we will be building now. So we'll go into 3D space, just load a very generic stir tank. Afterwards, we'll also look at a small HVAC example with particles, and maybe one more, as if the time allows. But you can already see, going from like standard rendering to ray tracing really helps to get some perception of depth and space, and especially for these streamlines here, it's really different. So yeah, let's start and go into 3D space of such a model and kind of explore some basic possibilities we have. Okay, so when we open MStar Post, we see this. Later on, I'll also use ParaView because for very complex scenes you should. But in principle, you're seeing the same. You see a mapping of color and opacity, right? And now it's in 3D. It's a bit more. There's a bit more to think about. And now that I see this, now that I scroll around and stuff, I can see that sharing my screen really slows me down a bit. So again, if stuff goes wrong, yeah, we will just redo it and it should work. So this button up here says enable ray tracing. So when I click this, I'm enabling ray tracing. And what I see here, it doesn't really look pretty. It's not, not interesting. It looks worse as before. We basically just expose two settings here. Okay. In ParaView, you have a few more, but this is basically what you need. Samples per pixel. Set the number of primary rays that ray tracers shoot per pixel. If we remember how ray tracing works, this determines the number of the rays we are shooting into the scene. So this is a really important number here. If we go too high, it will slow us down a lot. If we go too low, it will just look it will not look sharp and good. Another thing, when you're building your scene and you're navigating through space, deactivate ray tracing mode, because if I would rotate now, if I would zoom in and out now, it would just be painfully slow. Okay. Now, when we think about building scenes, there is basically, let's say, three components. The light source, by default, we have this key light. It consists of multiple lights, and we might want to turn it off and define our own light. So we have light, we have the objects that we want to show, and we have some kind of background. Okay, background can be just, I don't know, something like this. But usually to build a good scene, you want some, nicer background. Under scene, you can find some pedestals if you like those, or a light box, which I personally like a lot. So let me add a light box first. Let's just press apply and see what happens. Wow, it's really slow. And it crashed. Yeah, that must be the screen sharing that's messing me up a bit. Let's do it again. Now, fortunately, we didn't do anything, but this is a good reminder to really always save your state file, okay? And I'm sorry this happens a lot. Like if I work on my own, it doesn't, so it's not, you won't experience this. Lightbox, try again. Okay, so now we have this, this lightbox here. You can turn on and off some walls, you know, apply. Now I have this wall. 3 is enough usually, you know. You can increase the size here, X and C length. So now I have a bit more of a background in my scene. Second thing we were talking about, light source. Let's change this a little bit and add a custom light. Okay, so now I've deactivated the key light. I'm pressing add light, and this is what I'm seeing. Okay, so I can see a light that I can move around in space, the source as well as the focal point. We have a few default positions that you can choose from, so this is also kind of nice. Yeah, let's stick with one of those. Again, I don't want to, you know, waste too much time on everything. So yeah, let's stick with what we have. Very good. What else do we see? Intensity, coordinates, cone angle. You know, I can make it larger or smaller if I want. And this radius down here that I'll show in a moment. Before it crashes, I'll save my state, maybe just on the desktop. Okay. So now that we've set up a background, my object, and my light source, let's press the button again. Okay, and we can see it's super dark. The renderer is an entirely different rendering machine than your standard renderer. So some things might look different when you activate it. Okay. Let's enhance intensity of the light source. And let's do a few more samples per pixel. Okay, so now this already looks way more appealing and way more interesting. One thing you might notice is the shadow here is unnaturally sharp. Okay, that wouldn't happen in real life. And that's what we can change by this bottom radius, right? This is not the cone radius, not the cone angle. This is the radius of, let's say, your light source. So let's do something like 0.1 maybe. Let's give it a moment. Okay, and now we can see it's a lot more natural. One more thing you've probably noticed is the appearance of the tank, and most of all, like the free surface and the impeller is completely different, right? It tries to render real materials. If you haven't used this before, you know, maybe you've seen something like material here, and you've changed it and nothing happened. That's because we really need the ray tracer for it to function. So if I do material none here, and by default, you know, volume VOF surface has air water interface as a material. Let me turn those off just so you see the difference. Okay, so now you see this is more like, you know, your standard rendering, but still we get those great shadows, we get the light source. And something you might have also noticed, the longer you wait, the better the picture becomes. That's because this ray tracing algorithm is iterative, and you know it kind of builds up over time. Okay, now As I said, for scene building, I usually go with default lighting, default whatever, because it just works very well. Let's do this again. What else can we do with volumes? We can, for example, do isosurfaces, we can do streamlines and such. Let's do it. Let's use a contour filter here. Maybe vorticity, why not? And please, if you have any questions, go ahead. Okay, so now we have this. Vorticity is usually pretty nice to show some structure. You know, I'll go down with the number to have a bit more to see here. Okay, maybe that's interesting. Maybe I want to change the color. And we'll talk about colors as well in a moment, because if you've looked at some of my scenes, the colors are, you know, a bit more carefully chosen, let's say. Okay, isosurfaces work super well with this because they create very high contrast, right? We have very bright and very dark regions, depending on our light source. You know, now we also have that opaque surface, which kind of throws a shadow down here. But you can already see it makes it just look so much nicer. And that's not the only thing it does. It also, as I mentioned, it helps us a lot to understand, you know, position, like to get a better 3D representation, because it's just natural. It's what we would be used to. And let me turn off the light box for a second to demonstrate that. And now you can see the light isn't reflected anymore. So the regions that are in the shadow are a bit darker now, you know, so it's really natural what you're seeing. Okay, let me turn off this thing and add some streamlines, you know, to finish this flow only portion of my talk. Let's select the volume, filters, where are they? Stream tracer. By default, it uses this line where it spawns points. You can also do a point cloud, which is just a sphere. And by using the left and right mouse button, you can actually change the size and the position easily. Of course, you can also do it manually, obviously. Okay, let's hit apply. Now I'm not seeing a lot. That's because by default, these guys also use the opacity map. Okay, so let's deactivate that so that we see something at least. Okay, and also let me deactivate my sphere and follow my own advice. Okay. Now we see these streamlines, and the thickness of these streamlines is different in the renderer. That's just something, again, because it functions entirely differently. It's its own framework, you know, so we need to just see if it looks good or not. Okay, that looks interesting. Let me maybe deactivate the VOF surface for a moment. Again, it always takes time for it to render, so please excuse this. Okay, looks nice. Like if you do a close-up of this and kind of put it on your front slide for some kind of presentation, like that, people will love it, you know. That's already more than more effort than most people put into this. So and you can imagine when it's animated, it even looks a lot better, obviously. Let's make them a bit larger. And here again, we can see how much the ray tracing technology with the light source supports this three-dimensionality, let's say. Yeah, let's wait a moment. Okay. While this is loading, let's just go back to the slides. And let's get to, another example that you can watch. Yeah, I spend a lot of time building this scene. We have such a light box. We have volumetric rendering. I'm using a 2D slice here. I've extracted some of that ISO surfaces, put them up here. So that's all stuff you can do. I'm also changing the frequency at which I'm saving the data. I want to show the mixing as well as the rotation. And that's something that you need to think about before you make your data, right? You need to decide on the frequency at which you print your data. And that's even probably more important than making it look nice, because again, we're adding another dimension, in this case, time. So this adds a lot of, more depth to the whole experience here. Now, how can we estimate a good time step to highlight specific mechanisms? Can I get rid of that? Yes, I can. Again, it's probably not smooth, but I think we also put these short ones on YouTube. Emma, if you want, you can share the links here. If it's not smooth for you, it's smooth on my end. So in this example, let's go through a small calculation. This stirrer is running at 200 RPM. Okay, and that is 3.3 revolutions per second. Makes sense, right? One revolution has 360 degrees, obviously. By multiplying these, we know, okay, each second of flow time, my impeller travels 120 degrees. Now, if I want to make a smooth movie out of that, I only want to rotate a few degrees between the frames. Okay, in this case, I'm rendering with 30 FPS and I am moving the impeller by 3 degrees per frame. So that means 3 divided by total frames, if I look at the units here, gives me a good output frequency to smoothly resolve the rotation here. You can do 2 degrees or 1 degree if you want to slow it down. But this is kind of how I approach the output frequency question. It always depends on the time scale of what you're looking at, right? Again, we need to make decisions, and based on what we want to show, we need to adjust this as well. Another example. Here I have a mixing process. Okay, and I was simulating it before, and it was around 8 seconds. Now let's say in a typical presentation, you don't want to show super long movies, unless there is a lot of stuff happening in them. They can become boring quite fast, So here I'm saying, okay, I have 8 seconds of process time. I want to turn like my, physical scale, this It could be particles falling down. It could be a reaction, like just in this case, it's mixing, but you know, I think you get the idea. So I want to expand these 8 seconds into 20-second movie, for example. You know, that's a duration that's quite good. I would say between 20 and 60 seconds is usually where you want to land. Again, I need to decide with what frame rate am I rendering my movie. So how many data frames do I pack into 1 second of real time? I went with 30. I think the default is 15. 30 is just a bit smoother. That means I think I messed up yeah, no, makes sense. So in total, I need 600 frames, right? 20 seconds real time times 30 FPS is 600 total frames. So now I can just divide my 8-second process time by 600 total frames, and I'm getting an output frequency that will produce a smooth representation of the physics I'm looking at. Of course, you know, usually you don't know this in advance, but if you're really going to make a very complex scene, you run your thing first, then you look at the output frequency, and then you just rerun it to generate the data for the movie. You know, that's usually what you do. Okay. Any questions about this? Again, you'll have access to these slides, and you can kind of try it out yourself. But this is kind of the recipe that I'm usually going with. Okay. In that same space, we can briefly talk about time averaging. If you want to reveal time averaged properties, and you have something like a rotation, you know, some repeating motion, you should do the time averaging each time these blades are at the same position to reveal these kinds of structures. If you don't do it, you'll just get this, and you know, it's not very helpful. In this case, again, I have my 200 RPM, 1 RPM, yeah, 200 divided by 60 is my RPS. So I'm dividing by that value. I can then divide by 6 in that case because I have 6 blades, and I get my delta t, at which I should do my phase averaging. Now let's get to particles. Yeah, let's look at one example first. So here we see 2 types of particles, right? We see very big particles falling down, and we see very small particles down here in the bottom, and they emit light, which is also something I can show you. We need to treat these differently because, as you might imagine, if I have like thousands or millions of particles, I need to think a bit about how well I'm resolving them. Okay, if I like have a million particles and I resolve them very fine, everything becomes super slow, you know? So if I have a lot of particles, this should be good enough. You know, I don't need a lot of resolution on them. If I'm only looking at a few and I want them to look good, go with a high resolution here. Let's look at an example. And let me close this. Yeah, that's just the curse of presenting. I hope you understand. I'm sure everyone knows it. Okay. And in this case, I'm using ParaView also to highlight the workflow a bit, because it is different. I mean, ParaView, as most of you know, probably MStar is based on ParaView, and you see the interface looks similar, but you know, we just took a lot of stuff out that's not really relevant. Like if you look at the filters, for example, you know, it's a mess. It doesn't even fit on my screen here. So I highly recommend going with ParaView if you really want to build complex scenes. The reason also is you can use a small Python script to use the batch processing ParaView file. You save your state, and then it does the rendering in the background. And it's way more stable than using the GUI rendering. Okay, let's open files. The way you do it, let's start with few particles. The way you do it is you go into the output folder and open the PVD files directly, right? And we are saving particles with the slice frequency. So let's look at slice. What do we have? I don't want these slides. Okay, this should be good enough. Yeah, that's just a little system with inflow, outflow, free surface, particles, bubbles, stuff like that. Okay, very good. So this is, yeah, it kind of looks similar, right, to what you see in MStar Post. I can rename these, I can just say the M if I want. And I can also select materials. I can do anything I can do in MStar Post, right? So let's do something different to make it, to access the inside of the tank. Let's clip off something, let's say apply. Okay, and now now I'm only seeing this portion. Particles. By default, we are showing particles as point Gaussian. The renderer will not be able to see those, right? It needs faces. So what I really always need for rendered particles is a glyph filter. You can find it under filters. Here I have this little button. Let's see, what do we want? We want spheres, of course. This is where I'm defining the resolution. We'll look at that in a second. A scale array should be diameter. Let's scale it by 1. Apply. And it does something by default, which, is kind of interesting. Let's do time edit here, maybe. It does downsampling because they really know that, rendering too many particles can be difficult. But this is just a few, so let's show all of them. Let me close the light inspector. If you're not seeing the light inspector, you can just go to view, light inspector, and then it pops up here and you can define your own light sources. So if I turn this off and add a light, I can do positional, for example, which is similar to what we just did. Let me bring this maybe here. Why not? Show light, deactivate. Now, before I do the rendering, let's look at these glyphs a bit more. Save state. Do we need to down select the number of particles to be rendered in MStar pre-output? I would not do any downsampling, neither in post nor in pre. I'll show you how to render a lot of particles in a moment. Okay, let me just override this guy. I can also do surface with edges here, and it shows the resolution of my particle. And let's go up a bit. Let's do maybe 16 by 16. Apply, and you can see now it looks really smooth. Now let me do surface again. And let's just press the button. Now the button is not up here. In ParaView, you'll find it down here, all the way down here. Enable ray tracing. Okay, I'm clicking that. And then it has 3 ray tracers. Osprey Path Tracer is the one we're using because it also can render volumes, which seems to be quite hard for renderers, you know. But you can see like this looks so much better, right? They have shadows, they have everything. Like, it just looks so nice. Again, I can make the shadows smoother. What else is important? Here I can find the samples per pixel, what we discussed previously. Yeah, let's look at it from a bit further away. Yeah, I can also do this and just have a black background, you know, and the same logic applies. If you're navigating your scene, changing your stuff, disable ray tracing. But you can already see, like if I have a nice background, nice light source, all of these things, this will be a great image. You know, this will, like, people in presentations, in talks will love this. You know, maybe we want this to be a bit darker. Who knows? Yeah, I'm just trying out some stuff here. Not show the plane. Yeah, and now we really put the focus of the viewer on these, you know, particles here. These things also respect materials. The same we've seen in MStar Post. I'm going to skip those gas bubbles. I'll just make these guys look a bit like gas bubbles or droplets, you know. Where is the button? It is here. And now let's look for the materials. Here it is. What we call gas-liquid interface is called glass thick here. Should actually be glass, but I think it resembles free surfaces quite nicely. So let's pick that, enable ray tracing, and now it looks like these amazing droplets or, you know, glass marbles, whatever. Maybe it's a bit too dark. Yeah. Okay, so this is really how you would treat a small amount of particles, like up to a few thousand. You can increase the resolution to make them look very smooth. Now let us, yeah, I'll just do a new one. And now we'll render 1 million particles, right? And as I said, we'll go into this space now. Paraview, open. Okay, don't show again. Open. Many particles, output, slice. Yeah, these should be good enough. Okay, very good. So now I have my geometry. In this case, it's not a tank, which is nice for a change. And I have my particles here. I don't want to make this transparent. So again, I'll slice off a portion of it, the ceiling. Now I could do C normal, and go up. Yes, that's correct. Direction 2.5, maybe a bit more, 2.7. Yeah, that looks good. I'm not, you know, cutting away these this equipment here. And follow my own advice. Save. Okay. Particles. Yeah, I could do point Gaussian, but let's go right into glyphs. You know, we don't have too much time left. Same procedure. I'm using spheres, and I'm doing the lowering the resolution right away. You know, scale array. Let me go to the last time step. Doesn't find anything. Yeah, I think they should be a bit larger than they are in reality. Apply. Maybe that's not enough. Where are they? Diameter, coloring. Let's do solid. Yeah, now I'm seeing some. Okay, it does that downsampling again, right? We want to show all points. Okay, this is better. And again, what I'm showing now, if we zoom in, is this. You know, it looks really bad from close up, but let's check the yeah, let's give it some color as well. Maybe dirt, you know. Okay. And let's press the button. Path tracer. Okay, and let's make this dark. This. And again, if you have more questions, like obviously you can reach out to me at any given time. Maybe like this, but you can already see, like, I really don't need high resolution here, right? I'm showing a million particles. It's really good enough to have these very coarse particles. And I mean, it looks great, I think, you know. And you can imagine if you animate this, it will be spectacular. Now, okay, my geometry is a bit broken, you know, it looks a bit dangerous. Okay. One more thing we could show is maybe, yeah, using any surface as a light source. You know, I can use particles as a light source. I can add, I don't know, you know, a cylinder to create a real light in my scene or stuff like that. I'm doing that by, and let's never forget this. But it seems to be a lot more stable now. I don't know what was up in the beginning. Let's scroll up. Translation, no. Luminosity. If you make this larger than 1 and read the tooltip, you know, makes the object emit light. Only takes effect with Osprey's path traced. I'll turn off the light entirely. Enable my ray tracing. Now, why is it not working? Looks like it didn't use the correct renderer. Let me try again. Okay. Okay, that's a bit much. 1, 2. Oh, I'm so stupid, you know. I'm highlighting the clip and not the particles. Well, then obviously it doesn't work. Okay, now it works. Yeah, I mean, come on, that looks great. If you animate this, it will look amazing. With that, I think I'll finish the live demo and just show you a few more examples, unless you have questions. Any questions? No. Okay. Yeah, let's just discuss a few examples, you know. Okay, we've seen that one. One more point that's really interesting. Colors. Okay, and this is obviously a science on its own. You know, you have that color wheel, complementary colors work, analogous colors make a very harmonic picture. Split complementary is something you see very often. But don't bother with it unless you're really interested in it. And the way I do it is I just Google something, you know. I say, for example, color scale plus one or more keywords, and immediately you get very nice color scales that match and that you can use in building your scene if you really want to go that deep. Using the default colors and colorful color scales, it's totally fine. It's really up to you. Yeah. When you're building a picture, for example, like setting up your scene is obviously important. A mistake people usually do in the beginning is they zoom in a lot on the reactor or whatever they are showing. Your scene needs a bit of room to breathe. You don't want everything to happen here at the side of the image. Yeah, this is the one I made for this webinar. It's yeah, the physics behind it aren't really important, but again, we have isosurfaces, we have a light source, we have a background colored in this example. It's throwing a shadow on the wall to add depth to the scene. That's just thoughts you can include. You don't need to, but it's nice. This is another one that I made a while ago. It also looks pretty good. When you set up your camera settings, you can also define a focal plane and have stuff in the background blurred out, like in this example. Or in this example, this shows velocity as an isosurface, vorticity as an isosurface, complementary colors. Yeah, pretty good effect here. This is nice, this is just a rendered volume as we discussed right in the beginning when we started the live session. We have this jellyfish motion. In case you don't know how to get this into MStar, I can also help you. You can get deforming stuff into MStar, and you can see the shedding vortex down here. Really interesting physics going on. Particles, what we just discussed. I'm showing a lot of particles here. They are emitting light. That's pretty close to what we just did, but of course it's animated. And please watch them on YouTube, right? Don't take my bad frame rate here. What else? This is interesting. This was a project done with MGen on impulse mixers. Here I'm not using any volumetric output. I really defined the concentration as isosurfaces, which you can do in MStar Pre. It saves a lot of disk space. And it imitates a volume quite nicely if you have these different layers with transparency enabled, and all this stuff we just discussed. Yeah, that's pretty much it for me. Any final questions? You are very quiet today. To a box or plane in the same approach? Yeah, you can do that. Yes. Yeah, you can make anything luminous, but I think you can only do it in ParaView. How did you combine a 3D model of a vessel, a slice, and the impeller close-up in one image? I basically started with, I guess you're referring to something we saw in the beginning. I started with a volume, just volumetric data. Let's see, was it this one? No, this one. I started with volumetric data, and in ParaView, you can import volumetric data and slice data at the same time. You can also extract slices from volumes. So there's two ways to combine those. And here, I'm showing these isosurfaces and the impeller, and I'm using a translate filter. Under filters, I think it's translate, or maybe it's called a bit differently, but this lets you change the position in your scene. And I don't know if the webinar will stop automatically. here is
I'll go ahead
final,
and stop it
yeah.
when it's your time, Johannes, don't worry.
Okay, very good, very good. So if we are a bit, yeah, more questions. If there
I
aren't
neglected to
any,
mention this at the beginning, but I just want to say, if you've been coming to these webinars for a while, every beautiful image that we've used to promote these webinars has been made by Johannes. So we're really grateful for his expertise and artistry.
thanks, Amber. Okay, if there aren't any more questions, I have one final rendering for you that I made this week. Amber, you can also post the link if you want. This is really nice. You know, it's a combination of motion capture and CFD. I don't know if it's been done before, and I'm using the exact same techniques that we discussed today. So this is like in terms of setting up the scene, it's not hard to do. You know, I'm just using an isosurface for vorticity. I have a volume for velocity magnitude, and I have this light source from the top, as well as a plane on the bottom. Like that's really all. Have fun with it, be bold, try new stuff. Yeah, just have fun with it and treat it like a game. You know, that's how I usually approach it.